In this video, we're going to review motion graphs and learn how to find displacement from a velocity time graph. So first, let's look at the problem. A student walks 3 meters per second east for 10 seconds. They take 1 second to turn around, then they walk 2 meters per second west for 5 seconds. Okay, so it's a good idea just to, you can sketch this out like make a little picture first. So they're going to go 3 meters per second east for 10 seconds. So 3 times 10, they're going to walk 30 meters that way. And then they're here for 1 second. They stay there for 1 second as they turn around. And then they walk back 2 meters per second west for 5 seconds. So 2 times 5 is 10 meters. Okay, so they're walking 40 meters total. So let's sketch a distance time graph here. This is just a rough sketch. So you'll remember the slope of a distance time graph is the speed. So they're traveling at 3 meters per second. Let's say this is 3 meters per second. Then they stop for 1 second. So this is zero slope for 1 second. And then they keep moving at 2 meters per second. So the slope of this line should be a little bit less than the slope for this line. So that's the distance time graph. Maybe pause the video here and see if you can make a position time graph for the same student. So they are, remember the slope of a position time graph is velocity. So there's their velocity for the first 10 seconds, then zero velocity for 1 second, and then they come back.
Heads up class, your
They come back 10 meters back toward the origin. So we have a negative slope here. A negative slope, and this slope should not be quite as steep as the first slope because they're not traveling as fast. So a velocity time graph for this student. So first they're traveling at 3 meters. Actually, I'm going to draw it over here. A velocity time graph for this student. First, they're traveling at 3 meters per second. Then they stop for 1 second, so the velocity is 0 for 1 second. This is not to scale. All right, and then they travel at 2 meters per second west. So that is, west is negative. So they're traveling here negative. So this is 3 meters per second. We'll say that's positive or east. And here is 2 meters per second west. The instantaneous acceleration at 3 seconds. Well, at 3 seconds, the velocity is constant. There is no change in velocity at 3 seconds. So the slope at 3 seconds is 0. Therefore, the acceleration is 0. The acceleration between 10 seconds and 11 seconds. Okay, this is the part where they turn around. So if we write down the formula for average acceleration, we know it's the final velocity minus the initial velocity over the change in time. So the final velocity is 2 meters per second west. I'm going to use positive and negative. I just find it a little bit easier to do the math with positive and negative. So that's the final velocity minus the initial velocity, which was positive 3 meters per second. And the time it takes to change velocity is 1 second. So we end up with negative 5 meters per second per second. Put another way, negative 5 meters per second squared. Or, to be consistent with the question didn't use positive and negative. The question used east and west. So we can say meters per second squared west. Final answer. So part 2 is how do we find displacement from a velocity time graph? Let's look at the units for the x-axis and the y-axis. So the y-axis units are meters per second.
Sorry, what are we talking about?
Is meters per second. And the x-axis units are in seconds. So we're going at 8 meters per second east for 20 seconds. Okay, well 8 meters per second times 20 seconds gives us 160 meters. Okay, you could probably do that in your head. But let's look at the units here. If we just look at the units, this is meters per second, and we're multiplying it by seconds. Seconds will cancel, and the only unit left is meters, which is the displacement. Another way to look at it is this shape here, this rectangle. What we're doing is we're multiplying the length, 8, times the width of 20. Right, this is the length, and this is the width. And when you multiply the length times the width for a rectangle, it gives you the area. So in other words, the area between the line and the x-axis, this area here, is the displacement.